Exercise 12.3 Problem 1 to 5 Solution. If psi is an impossible event, then probability of psi equal to, they have given us four options. If an event is impossible, probability of that event is 0. Right? It's a known fact. The probability of a sure event is 1. So probability always varies between 0 and 1, but including 0 and 1. So when the event is impossible, it is 0, and when the event is 100% surely possible, then it is 1. Okay, so in this case, it is basically 0, so it is option C. Right, let's go to second problem. If S is a sample space, okay, S is a sample space of a random experiment, then probability of S is 1. Because sample space includes all the possible outcomes. So probability of S means your probability of all the outcomes. So which is nothing but 1. Okay. So in this case, it is option D. Sample space is a set of all possible outcomes of a random experiment. Therefore, probability of the sample space is nothing but 1. Okay. Right. For example, let's say when you toss a coin, the sample space is either it will come head or tail. So H and tail is the H comma T is your sample space. If I say probability of the sample space means probability of head or probability of tail, right? So which means it is 1. So 1, either you will get head or you will get tail. But if you include both as a favorable outcome, the probability is equal to 1. Okay. Next, let's go to the third problem. If P is a probability of event, then P satisfies, probability always lies between 0 and 1, including 0 and 1. So it is this option. Okay, so P satisfies 0 less than or equal to P, P less than or equal to 1. As I told you earlier, probability of an impossible event is 0 and the probability of a sure event is 1. Okay, right, let's go to problem 4. So let A and B be two events and S be the corresponding sample space. Then probability of not A intersection B equal to. So probability of A bar, that is not A, intersection B is. So basically you want to get of it is probability of B but not A. So that is nothing but it is probability of B minus probability of A intersection B. It is like probability of B minus A. If you remember the set operation, what is B minus A? So the shaded portion of B, the total B minus A intersection B, right? So that is what you used to do in the set theory. So it is equivalent to probability of B minus A, that is probability of B but not A. So that is probability of B minus probability of A intersection B. Option A. So these are standard formulas. You'll have to go through that. It is given in the books. So let's go to the next problem. Problem 5. The probability of the student will score a centum in mathematics is 4 by 5. The probability that he will not score a centum is, they have given us 4 options. So probability of not scoring is 1 minus 4 by 5. The probability of student not scoring centum is 1 minus probability of scoring centum. So probability of scoring centum is 4 by 5. So it is 1 minus 4 by 5. So that is 1 by 5, which is option A. Okay. So I hope it's clear. If not, please go through one more time. But please remember to go through all the formulas also, because some of these questions are based on the formulas, like what we saw, probability of not A intersection B, okay, or probability of A bar intersection B. So those kind of things are ready-made given in the as a formulas. So if you know that, you can straight away answer the question. Okay, thanks for watching this video.